Welcome to the 2020 Farm Science Review Gwen Conservation Area virtual presentation of woodland fungi identification. A walk into the woods with Curtis Young, OSU Extension Ag and Natural Resource Educator from Van Wert County. We start today with the horse mushroom, Agaricus arvensis. This is a big mushroom that grows in similar areas as the meadow mushroom, Agaricus campestris, but this one is bigger, much bigger. These were growing in a fairy ring, and as I walked in the circle of mushrooms, it looked like white chicken eggs deposited in the grass. There were a few that had emerged earlier and were fully expanded mushrooms. I have removed some of the mushrooms from the soil to look at its characteristics. This is a fairly matured horse mushroom, fully expanded. It is a gilled mushroom, and its gills start out pink in color, but later turn more brown as spores are matured and shed from the gills. It has a thick, sturdy stalk and a large skirt-like annulus ring. The base of the stalk lacks a vulva or cup and connects directly to the soil. Here are a couple of button stage horse mushrooms early in their growth. Note the veil over the gills. This is what becomes the annulus ring as it tears away from the rim of the cap. It is somewhat amazing how such little buttons grow into such monster caps. This pair provided an in-field spore print. We highly recommend making spore prints for identification. Spore color is an important ID characteristic. These spores are a purple-brown color, and it has changed the gill color to a more brown color as well. The spores were shed and fell on top of the mushroom growing below the first, and it's showing the purplish-brown coloration of the spores of the horse mushroom. Other mushrooms will be white-spored, yellow, pink, tan, or even black in color. Our next very common mushroom is the ringless honey mushroom, Armillaria tabaciens. It's very common in both urban and rural habitats. Here are a couple of clusters growing very close together in a lawn environment. They are associated with tree roots and may cause serious root rot. I've dug free one of the clusters to show that numerous stalks are growing from a common point. This mushroom lacks an annulus ring. It is a gilled mushroom as well, where in this case the gills are called decurrent because they extend down the stalk for a distance. Ringless honey mushrooms have white spores, and most have a honey brown cap color. These ringless honey mushrooms are growing around a tree stump in a woodlot. These are well developed, while others on the same stump are still in the process of expanding. So you can see the caps are not fully open. But also note all the insects hanging around the mushrooms. Here are several other clusters of ringless honey mushrooms, and they are growing around a different stump. And the fate of many of these honey mushrooms is that they will be devoured by the insects that love to eat fungi. And they have turned these honey mushrooms into a pile of goo with hundreds of insect larvae, most of which are fly maggots, and maybe some beetles. As we look around, we'll see some that have not quite succumbed to the insect activity and extend out into the soil following the dead tree root as it goes through its path into the soil. The next mushroom I found in the woods was the jack-o'-lantern, Ophilotus oleracus. Jacks look very similar to ringless honey mushrooms and grow in a similar location, and like the ringless honey mushroom, they tend to grow in clusters. However, jacks are orange in color through and through, and unfortunately, they are also toxic if eaten. Just how similar are these jack-o'-lantern mushrooms to the ringless honey mushrooms? Well, here you can see a cluster of them growing inside of a stump of a dead tree. and there are multiple stalks coming from a similar growing point. And environmentally, they grow in very, very similar locations. Here we are panning back from the stump where these jack-o'-lanterns were growing, going a few feet across the pathway through the woods, and just on the other side of the path is a stump that is surrounded by ringless honey mushrooms. What I almost missed at this same location was another species of mushroom called the aborted Entoloma. And as we pan in on this group of ringless honey mushrooms, we'll see an odd-looking white ball structure growing behind them. This is actually an interaction between the Entoloma and the honey mushroom. And when the two combine, they form this unusual structure. Now, I'll dig it out of the soil so you can see that it looks like just a ball of who knows what. And when you cut through it, you can see some pink spores on the inside. That's the result of a honey mushroom interacting with an Entoloma. Variation also exists in the honey mushrooms in terms of their color. Here you see a cluster of honey mushrooms that are basically yellow or golden colored. It is the exact same species, the same exact species characteristics, all those stalks coming from a common growing point, and the brown versions growing on the other side of the very same tree. The next mushroom that was discovered this day was a fresh growth of chicken of the woods, Laetoporus sulphureus, right at the edge of the trail coming out the end of a log stump. The chicken of the woods has a yellow underside from which the white spores are produced. Actually, they're somewhat colorless spores, but they appear white. The chicken of the woods can grow singularly or, as you can see here, as overlapping plates. This is a fairly fresh one, and so the colors of orange and yellow are still very vibrant on this specimen. And chicken of the woods is very common. It can be found on a number of different species of trees. Oak seems to be a favorite. Here's an early growing stage of chicken of the woods. It's hard to believe that these little clusters of yellow will eventually grow into a plate, as we saw in the previous example. But this is how they start, kind of oozing out of a crack in the log, which was most likely an old oak log laying on the ground. Chicken of the woods is considered to be an edible one and is sought after by mushroom hunters on a regular basis. Just a little further down the trail from where that chicken of the woods had been growing, I almost missed the next fungus that was growing at the base of this rotted log. And what it was an earth star puffball. The earth star puffball kind of blends in very well with its surroundings. And if I hadn't been paying it close enough attention, I would have walked right past them. They start out as a solid ball about the size of a small ping pong ball or a shooting marble. And as it ages, the rind on the outside will split open to produce a star-shaped structure and reveal the puffball growing on the interior. Sometimes they're completely hidden by the almost mulch-like material coming from the rotting log. And I'm moving a few aside, and I'll roll this one over, and you can see why it's called an earth star. It kind of has a star-shaped appearance to it. As they mature, a hole will generate on top of the puffball through which the spores will be released to the outside world. Going back out into a grassy area around another stump of an old tree that had been cut down, I came upon lacquered or varnished polypores called Ganoderma sessile. For years, people thought these were Ganoderma lucidum, common name being lingqi or reschii, but they are a completely different species. In fact, we do not have Ganoderma lucidum in the United States, according to some researchers. Note the top of the polypore has a very glossy to nearly shiny appearance to it in the brown areas of that polypore. The plants that appear to have grown through this fungus were actually engulfed by the fungus as it was growing around the plants. As I've mentioned, this fungus is a polypore, and when you pull one up and look on the underside, you will see the pores through which the spores are released into the environment. This is an annual growth, and unfortunately, when a tree stump is in a lawn area, these can return year after year and cause some problems with mowing around that stump. And there you can see the remains of the most likely big silver maple that was cut down, upon which this Ganoderma is continuing to feed. This one I'm going to pull up to look at the bottom side of it. It does have some resistance of being removed from the stump, and actually the resistance is from the weeds that the polypore has grown around. And on the underside, you can see that there are some patches that also have that lacquered appearance. But as I pan in on the bottom of the fungus, you can see that the surface does have numerous little holes through it, through which the spores are released into the environment. Again, this is Ganoderma sessile, actually a fairly common fungus. Growing right in amongst those was a common bonnet, also sometimes called a common mycena, or in typical terms, it's a little brown mushroom. It's called a bonnet because the cap kind of looks like a hat or a bonnet that a woman would have worn in days of old. It is another wood decomposer. It is very common. It can be found just about in any urban and rural environment. It's a delicate little mushroom, very thin cap. It is a gilled mushroom, and here in a second I will remove one of the specimens and look on the underside. Genus species name is Mycena gloriculata. You can see the fine gills that almost connect to the stalk. No annulus ring once again. And the stalk connects directly to the soil, or will be connected directly to a piece of wood that it's growing out of. Another very delicate little wood decomposing mushroom is one that is stalkless and is called the flat crep mushroom. Crepidotus apollinatus. It is a small white stalkless mushroom that grows on decomposing wood. Many can grow on the same log, and you can find that many of them have also been eaten upon by an organism of one sort or another. And again, there is no stalk on this little mushroom. It connects directly to the wood surface that it's growing from. Here's a couple of the flat crep mushrooms that you can see something has eaten them. And there's the culprit. Slugs love to eat mushrooms. And our little slug friend here is moving as rapidly as he can toward the feast that grows on the log just below him. Here's another view of the flat crep fungi. And notice all the mycelium that's growing on the bottom of that log, and that mycelium will collectively come together for reproductive purposes and produce the little fungus that you see growing out the side of the log. Uh, Very pretty little mushroom. Another mushroom that grows on dead logs is called the false turkey tail. And the false turkey tail, Sterium austrea, is a parchment fungus. And it's called false turkey tail because it resembles the true turkey tail, but there is a major difference to tell the two of them apart. The false turkey tail is a parchment fungus, whereas the true turkey tail is a polypore. The parchment fungi, when we pull a sample of it off and look on the underside, will not have any visible pore openings through which the spores would be released to the outside environment. So this is the underside of a false turkey tail. And as close as you can get with magnification, you will not be able to see any kind of openings on the underside of that parchment fungi. Very thin, almost paper-like, thus called parchment. Some of the coloration that you see there is actually algae growing in the body of that parchment fungus. On the same log, true turkey tail was growing, and true turkey tail is Trametes versicolor, and the two of them grow side by side. So right down the middle of this American beech log with a bright white rim on them were the new turkey tail. Here is some additional true turkey tail growing on a branch in a fairly dense cluster. And you can see the colors of it are a little bit more muted than what we saw on the false turkey tail. And here in a second I'll pull a piece off. And when you look on the bottom of the true turkey tail, you can see that it is a pored surface. So this is your field identification characteristic. Another fungus growing on the very same log was the shaggy bracket polypore. And the shaggy bracket polypore, notice hispidus, is kind of a bland little fungus in terms of its appearance. It's mostly tans and browns. And as it ages, it'll just turn dark brown and be fairly nondescript. But the one thing to notice on this polypore currently is all the water droplets. Apparently, some of the fungi have a unique ability to pump water through its mycelium to its reproductive structures. So even though it was a relatively dry summer, there is a large quantity of water droplets that are accumulating on the surface of these polypores, and it was not a dewy morning, nor was it a rainy afternoon. This was just the water that was gathered by the fungus and pushed to the surface of that reproductive structure to assure reproductive success. This is an annual fungus, and it is relatively soft. It's very pliable, spongy. And when I turn it over, you can see the pore surface of this polypore, again, through which the spores will be released. And look at the amount of water that's accumulated in that tissue. The other thing is, because there is a fair amount of water accumulated in the bodies of this fungus, insects love to feed on it. And so you can see the frass or the poop of insects exuding out of holes that have been eaten into them by either a beetle or a fly. Another parchment fungus is the crowded parchment, Sternium complicatum. And this is a very common parchment fungus, especially on hardwoods like oak. And this is a limb off of an oak tree that's fallen to the ground. It's called crowded parchment. As you can see, there's lots of it that grow collectively in a common area. And so It has this typical yellowish brown coloration. Uh, it is a parchment fungus, so it's in the same genus as the false turkey tail. If you try to look for any kind of pore openings on the surface, on the underside of this fungus, you will find no openings. So it will be a smooth, paperish appearance to it as well. A very common, easily identified fungus is the artist conch polypore, Ganoderma appellatum. This polypore is a perennial polypore and can add onto itself for many years as long as it's not disturbed on whatever decomposing wood it's living on. In fact, you can cut through that growth and see rings of growth from the annual growth that's added onto that on a regular basis. Some of them can get quite large and have grown for several years in a row. It's called the artist conch because of that bright white undersurface of the polypore that pioneers could collect and etch artistic scenes into them. And if that was managed well, it could preserve that scene for very long periods of time, sometimes 20, 30 years or more, if it was well protected. These artist conch release millions of spores when they're producing spores that are kind of a brown chocolate coloration, and it will coat that stump, the ground, and the upper surface of that bracket with that spore production. And if you're there at the right time, it will almost look like that polypore is on fire because of the amount of spores being released. This is one of my favorite oak trees to look for different types of fungi growing on it. It used to be one of my best trees for producing chicken of the woods, but that was before it fell to the ground. The polypore that is present on it at the current time is called a thick mazed oak polypore. It's a little less obvious than the artist conch or the chicken of the woods, but it is kind of a unique little polypore when you get up close and look on the underside. On the underside, you can see instead of having a smooth, flat surface with holes through it, it has what almost looks like a hedge maze underneath it. Very thick ridges that stand up from the undersurface, and you can understand why somebody called it a thick mazed oak polypore. You can almost identify oak wood in the woods by the presence of that polypore on it. Like I said, this is my usual tree for finding chicken of the woods, and, well, sure enough, just going over a few feet from where that thick maze polypore was located was a chicken of the woods. And you can see the typical orange and yellow coloration of the top, and underneath, for the chicken of the woods, it has a yellow undersurface through which the spores are produced. Another really common fungus in Ohio woodlots is the white jelly mushroom. And it looks and feels like white jello, slimy and rubbery. It grows on numerous different hardwood species, and it can appear multiple times through the growing season as long as moisture is available. It will eventually age and turn more of a tan color, but it is fairly easily identified by its gelatinous, rubbery appearance and being relatively pure white in color. It almost looks like Play-Doh that has been squeezed through a mold and exuding out to the surface of the trunk. There are other jelly fungi, such as witch's butter, which is a bright yellow coloration. There is also one called tree ear, which is basically a brown color, a little bit larger than the white jelly, and it kind of looks like an old man's ear when you find that particular species. The next fungus that I came upon in this particular woodlot was a giant puffball, an aged giant puffball, but a puffball nonetheless. Uh, when the giant puffballs first grow, they will be white in color through and through. And obviously, this one is not white anymore. It has completely matured. The outer covering has turned basically a brown color, and the interior material, which is just chock full of spores, is a garish green color. And from that, millions of spores will be released into the environment. And you can see that the outer rind has split open to release those spores into the environment. It was not necessarily attacked by anything, that's just how they break open. However, if you look on the left-hand side of that puffball, you'll see kind of a moldy appearance of a mycelium growing on it. And yes, there are mushrooms that feed on other mushrooms. So that one had a bit of a mushroom infection. One of my favorite little mushrooms to find in the woodlot is the orange mycena. And the orange mycena is a small, delicate mushroom that has a tangerine orange color when it is fresh. It's a very photogenic little fungus and can produce some beautiful shots, even in the darker areas of woodlots where it typically grows. There are numerous different species of mycena mushrooms. This one happens to be one of the more common ones, or at least the more obvious ones because of its coloration. And again, it grows on many different species of hardwood trees. You can find them singularly or in very large clusters. Another orange-colored mushroom that is somewhat common in woodlots in Ohio, a little bit more muted in its orange color, is the mock oyster or orange oyster mushroom. It is a late summer mushroom, also stalkless, and it grows on fallen limbs and logs of a number of hardwood trees. Its muted orange color reminds me kind of a orange creamsicle. Sometimes it can be a bit more intense than what we see on this example, but it is, again, a very common mushroom. It is a guild mushroom. In this image, you can see the gills up underneath that stalkless mushroom growing out the sample of wood. It does have kind of a fuzzy rim to the cap of the mushroom as well. And finally, the last fungus of the day was the split gill mushroom. And I really love the genus species name of this one. It's Schizophyllum commune. So it does grow in groups, and it's called split gill or Schizophyllum because when you look at the underside of the little stalkless mushrooms, the gills will have the appearance that they split as they go out toward the edge of the cap, and that's lengthwise. And so you see all of those gills are extending from the connection point to the wood outwards to the edge of the cap. And the gills toward the ends appear to split or Y. So that's this split gill mushroom growing on hardwood. In this case, it looks like it was a piece of shagbark hickory. It does grow on many different types of hardwood, and it can be an indication of serious rot in a standing tree.